Welcome to this openCARP tutorial. In this tutorial, we will learn how to create and run a single-cell experiment, how to modify the cell parameters, and the concept and use of the plugins. Looking at the action potential of the cardiac cell, we can define some characteristics. We can define the resting membrane potential, or RMP. We can define its amplitude, the maximum value of the derivative of the transmembrane voltage with respect of time or steepest slope, and the duration of the action potential or APD. A short reminder, the action potential is the combination of the opening and closing of ion channels. What happens if we modified one or more parameters of an ion channel? Will that, for example, modify the duration of the action potential, making it longer or shorter? To answer those questions, we will create a single-cell experiment using CARP utils. Our experiment will consist on modifying one potassium current. So we have the question, what will happen if, for example, we now modify the maximum conductance of this channel? Will the action potential decrease or increase? Let's use CARP utils to create a single-cell experiment using Bench. Bench is a tool of openCARP created to test ionic models and that allowed us to create single-cell experiments. First, we will have a closer look at the structure of a CARP utils file, and we can divide it in 4 parts. The first part is where we are importing the CARP utils Python module. The second part is the parser function. This will allow us to query the CARP utils help and also to modify specific parameters of our experiment. Then we have the job ID function, which will create a folder to store all the outputs from the simulation. And finally, the main function, in which we are going to program our experiment. In this tutorial, we will be using Bench. So first, we will start by calling the executable. In this line, you can see how we call Bench. After that, we will define the ionic model. We will use the formulation proposed by Courtemanche et al., which represents a human atrial myocyte action potential. Then, in this line, you can see how we call Bench. We have different options we can use in our experiment. IMP part allows us to modify some parameters of the ionic model. Now, a plugin is an external current which is not defining the original model, but it can be added to the formulation. And we can see here in this section how we can call that. We can also modify some parameters of the plugin by using plug -par. After that, we are setting up the stimulation current, and we can also play a little bit with the number of stimulus, the basic cycle length, duration of the simulation, and to end, here we will be actually running Bench. Now, how can we run the Python script? Now, to run the CARP utils Python script, we will type in our terminal python space run.py and enter. Then CARP utils will take care to put everything together and run the simulation. Now we just see that our simulation finished, but we don't see any action potential. How we can do that? So we will type again python run.py -- visualize and run the experiment again. Now we can see the action potential of a cardiac myocyte. Now we can use the same experiment to answer the question, what happens if I modify one ion channel? To modify a parameter of an ionic model, we can type -- imp_par and the channel that we want to modify. In this case, we will modify a potassium channel. And first we would like to see what happened if we multiply it by 1.6. Then again, minus minus visualize, and to compare the result with the baseline model, we can use the option minus minus overlay true and run our experiment, and now we can see that the orange curve is the action potential of the baseline model, and the blue curve is now the remodel action potential. What happened if instead of 1.6 we multiply it by 0.6? We should see the opposite effect. And now it's clear that if we reduce that potassium channel, the action potential will be longer compared to the baseline. And if we increase the conductance of that ionic channel, we are reducing the action potential. So we can see how useful is an experiment using CARP utils. Now we will go back and remember what is a plugin. So as I mentioned before, the plugin is a formulation of an ionic current which is not present in the model. So to include the formulation of an ionic current, now to run our experiment with the plugin, we type python run.py minus minus plug underscore in, then the name of the plugin, which in this case is the formulation of the acetylcholine current, and then we would like to visualize the result and compare with the other simulations that we run. Now we can see that actually our curve, it's here, it's underneath the blue curve, which is the effect of adding the plugin. So just by adding the plugin, we can see that the action potential now it's reduced. To summarize, now in this video tutorial we learn the general structure of a CARP utils script. We see that we have 4 sections. The first section is where we declare the Python models. Then we will have the parser function. Then we will have the job ID function. And after that, the main function. We also learn some characteristics of the action potential. Then we learn how to modify specific parameters of an ionic model, and we saw their influence. We saw that the action potential got shorter or longer. We also understand the influence of increasing or decreasing these ionic currents, and we learn about the concept of plugins and how to use them. Thanks for watching.